Assalamu alaikum. Student, today our topic is arithmetic series. We define arithmetic series as the sum of the terms of an arithmetic sequence is called an arithmetic series. In general, an arithmetic series of n terms with a as its first term and d as its common difference. We can write arithmetic series as a is the first term, a plus d is the second term, plus a plus 2d is the third term, plus up to so on a plus n minus 1 of d. The sum of the series, let's suppose we have an arithmetic sequence. We say as for example 3, 5, 7 and 9. Here we know that the first term is 3 and the common difference 5 minus 3 is 2. So it is an arithmetic sequence. First term is a, second term is a plus difference, which is a fixed number. Third term is a plus twice of d, and similarly nth term will be a plus n minus 1 of d. So if we find the sum of these terms, the sum of these terms will be, and the sum of terms we can define the sum of term as n times the mean. What is the mean? First term plus last term upon 2. So we know that the first term is a and the last term is a plus n minus 1 of d. So n first term is a plus last term is, this is our last term, a plus n minus 1 of d upon 2. A plus a is 2a. So this is 2a plus n minus 1 of d upon 2. So sum of the term we call series. So we say S and we denote the series of n term. Sum of the n term is Sn. So this will become n upon 2, 2a, a plus n minus 1 of d. This formula we use for finding the sum of the arithmetic series. So we are going to do exercise 6.2. So in exercise 6.2, question number 1. Question number 1 is find the sum of each of the following arithmetic progressions to the indicated number of terms. The one part of question number 1 is the sequence is 1, 5, 9, 13 to 48 terms. 40 terms. So with the help of this formula of sum of the series, we find the series of the sum of this sequence. Here a is equal to 1, the first term, and the d is the difference. So second term minus first term, 5 minus 1 is equal to 4. The difference is 4. If we subtract 9 minus 5, we get 4, and 13 minus 9 we get 4. The difference is fixed. We say this is the arithmetic sequence or progression. Here n is 40, is the indicated term, and by using the formula of sum of the series, Sn is equals to n upon 2 2a plus n minus 1 of d. So we know that Sn is equal to n upon 2 2a plus n minus 1 of d. By putting the data in this formula, here n is 40, a is 1, n is 40 minus 1, and the difference we find 4. So here 40 upon 2, 2 plus 39 into 4, 156. This is 39 and multiply by 4. So simply 40 upon 2, 2 plus 39, 4s are 156. 20, 2 plus 56 is 158. We get 3160 by multiplying 158 with 20. The sum of 40 terms, here n is 40, are 3160. N is 40. So with this formula, we can do all parts of question number 1 easily. Now we see question number 2. In question number 2, find the sum to n terms. Find the sum of n terms of arithmetic progression whose first term is 1 upon n, and last term is n square minus n plus 1 upon n. We find the sum of n terms. By using the same formula here, data is the first term a is 1 upon n, which we call also t1, and the second and the last term tn is equal to n square minus n plus 1 upon n. We know that the last term tn can also be defined as a plus n minus 1 of d. By using this formula, we find the value of distance d, and then we use formula of sum of the series. Here last term is given as n square minus n plus 1 upon n. We put the value of last term tn in the in place of Tn is equal to, the first term is an. A is given in the question 1 upon n plus n minus 1 of d. N square minus n plus 1 upon n is equal to, here we take LCM, so 1 plus n will be multiplied with this term and n minus 1 of d. This n will be cancelled with this, so we get n square minus n plus 1 is equal to 1 plus n minus 1 of d. One will be cancelled with this. N square minus n is equal to n minus 1 of d. We can take n as a common, so n minus n minus 1 of d. This term will be cancelled with this and we get 1. The common difference is 1. Now we use the formula of sum of the series, which is Sn is equals to n upon 2, 2a plus n minus 1 of d. It becomes Sn is equals to n upon 2, 2a. The value of a is 1 upon n as given in the question, plus n minus 1, and the d we find here 1. So Sn is equal to n upon 2, this is 2 upon n plus n minus 1. As n upon 2, we take LCM n, so 2 plus n will multiply with this term, so Sn is equals to n upon 2, 2 plus n square minus n upon n. Sn is equals to, this n will be cancelled with this, so 2 plus n square minus n upon 2. So we find the sum of the series by using the given data. Sum of the n terms is equal to n square minus n plus 2 upon 2. This is the required answer. Now we are going to start with question number 3. In question number 3, in the following question, there of the 5 elements A, L, D, and Sn of an arithmetic progression are given. Find the missing element. So in one part of question number 3, we are given the value of A is equals to 3, value of D is 7, and the value of n is 9. We have to find the sum of the n term Sn, last term, because we are given 3 terms A, D, N, and in the question there of the 5 elements, so the remaining elements is Sn and the last term Tn. Solution. We know that the sum of n terms is equal to n upon 2 2a plus n minus 1 of d by putting the values of given data in the formula. Sn, here n is 9, Sn is equals to n upon 2a plus n minus 1 of d. So here n is 9, S9 is equal to 9 upon 2, a is 3 plus n is 9 and d is 7. So 9 upon 2, 6 plus 8, 7 are 56. 62. Sorry. So we can divide 62 and 2. 2, 3 is 6 and 31 nines are 279. So Sn is equal to 279. This is the required one element, and after Sn we have to find the last term. So we know that last term is Tn and its formula is a plus n minus 1 of d. So the last term we can find n is 9, T9 is equal to a is 3 plus n is 9 and the difference is 7. So here 3 plus 9 minus 1 is 8, 8 plus 8 7 are 56 and 56 plus 3 is 59. So Tn is equals to 59. So in part 1, question number 3 is a is equal to 3, d is equal to 7, n is equal to 9, Sn is equal to 279 and the last term is equal to 59. Similarly, in part 2 of question number 3, the given data is a is equal to 3, d is equal to 6 and Sn is equal to 363. So we have to find n and the last term. So by using the sum of the n term, we know that Sn is equal to n upon 2 n minus 1 of d. We don't know the value of n, so n upon 2, the value of a is 3 plus n minus 1 and d is 6 and s of n is 363. 6 plus 6n minus 6. This is 6 and minus 6 plus 6 will be cancelled. So 363 is equal to n upon 2 into 6n. Okay. This is 363 is equal to n upon 2 into 6n. 363 is equal to 3n square. So 363 upon 3 is equal to n square. 121, and the value of n we take root, so n is equal to plus minus 121, we get n is equal to 11. Similarly, the Tn last term, by using the formula a plus n minus 1 of d, we get n is 11. So put the value of n t 11 is equals to a is 3 plus 11 minus 1, and the difference is 6. 11 from is equals to 3 plus 10 6 are 60, and 60 plus 3 is equals to 63. So in this way we find the value of n and the last term also. So we can do all parts of question number 3 easily by using this formula of Sn and Tn, sum of the n terms and the last term. Now question number 4 is if 1 plus 3 plus 5 plus n terms two plus 4 plus 6 plus n terms is equal to 0.95, and you find the value of n. Question is find n. Solution. Since we know 1 plus 3 plus 5 plus n terms, upon 2 plus 4 plus 6 plus n terms is equal to 0.95. This we say equation number 1. We use some of the n terms formula of Sn here. We know that the formula of Sn is n upon 2, 2a plus n minus 1 of d, n upon 2 plus 2a plus n minus 1 of d is equal to 0.95. Here in this progression or sequence, we know that the value of a is 1 and the difference is 3 minus 1 2. So here a is equal to 3 and the difference is 3 minus 1 is equal to 2. And the sequence in the denominator, we have the value of a is 2 and the difference is 4 minus 2 is equal to 2. So we use formula here by putting the values of this a and d in the formula. So equation 1 implies n upon 2 2a plus n minus 1 of d upon n upon 2 2a plus n minus 1 of d is equal to 0.5. We can n upon 2 will be cancelled with n upon 2, and we get 2a plus n minus 1 of b upon 2a plus n minus 1 of is equal to, we can write 0.95 as 95 upon 100. So we put the value of a is 1 plus n minus 1, the difference is 2, and in this progression the value of a is 2 plus n minus 1 and the difference is 2. 95 upon 100. So 2 plus 2n minus 2, 2 to the 4 plus 2n minus 2. Minus 2 will be cancelled with 2. So 2n upon 4 minus 2, 2 plus 2n is equal to 95 upon 100. We can take 2 as a common. So 2n upon 2, 1 plus n is equal to 95 upon 100. 2 is cancelled with 2. So here n upon 1 plus n, and multiply the this 5 9s are 45 and 20 19 upon 20. So by cross multiplication we get 20n is equals to 19 1 plus n. 20n is equals to 19 plus 19n. 20n minus 19n is equal to 19. N is equal to 19. So the value of n is 19. Similarly, in question number 5, we are given a question. If the sum of 8 terms of an arithmetic progression is 64 and that of 19 terms is 361, find the first term, common difference, and the sum of 31 terms. Okay. If the sum of 8 terms of an arithmetic progression is 64 and that of 19 terms is 361, find the first term, common difference, and the sum of 31 terms. Solution. Let A be the first term and B be the common difference. Sn is equal to n upon 2, 2a plus n minus 1 of d. In data, we given sum of 8 terms is 64. So n is equal to 8 and S8 is equal to 64. By putting this data in the formula, S8 is equal to 8 upon 2, 2a plus 8 minus 1 of d, and S8 is 64 is equal to 4, 2a plus 7d. So 64 upon 4 is equal to 2a plus 7d. 4, 6 are 24. So 16 is equal to 2a plus 7d. This we say equation number 1. And the second given condition, and that of 19 term is 361. That means n is equal S19 is equal to 361, implies n is equal to 19. So by using this formula, we can get our equation number 2. So n is 19 upon 2 plus 19 minus 1 of d. So 361, as the sum of the 19 term is 361. Sum of the 19 terms are 361. We put the value of sum of the 19 terms in the place of S19. 19 upon 2, 2a plus 18d. (361) is equal to 19 upon 2. We can take 2 as a common. So a plus 9d. And 2 is cancelled with this 2. So 369 is equal to 19, a plus 9d. So 361 upon 19 is equal to a plus 9d. And 19 are 361 is equal to a plus 9d. So we say this is our equation number 2. And by solving simultaneously equation number 1 and 2, we get the value of d. So equation number 1 is equation number 1 is 2a plus 7d is equals to 16. And equation number 2 is a plus 9d is equal to 19. Sorry. We separate these two equations. By multiplying equation number 2 with. So we separate these two equations and get the getting the value of d. Equation number 1 minus twice of equation number 2. Equation number 2 will multiply with 2. So we get 2a plus 7d is equals to 16. Here 2a plus 18d is equal to 38. And we separate these two equations. Minus 2a plus 2a will be cancelled. Here we get minus 11d is equal to 38 minus 22. Minus cancel with minus. D is equal to 22 upon 11, which is 2. So we get the value of D is 2. And by putting the value of D in any equation, we get the value of A. So here A plus 9D, by using this equation, put the value of D, which is 2. 18 is equals to 19. A is equal to 19 minus 18. The value of A is 1. So here the value of A is 1 and value of D is 2. We have to find find the first term, common difference, and the sum of 31 terms. Now we find the sum of 31 terms. We find sum of 31 terms. So n is equals to 31, and here we use the value of A is 1 and the value of D is 2. So S31 is equals to 31 upon 2. 2 plus 2n minus 2. Minus 2n plus 2 will be cancelled. There's a mistake. We put the value of n, which is 31. 31 minus 1, 2. So now we get n up S31 is equal to 31 upon 2. 2 plus 30 into 2. So S31 is equal to 31 upon 2. 2 plus 60. 31 upon 2, which is 62. 31. S31 is equal to 961. So the sum of 31 term is 961. And A is 1 and the common difference is 2. In question number 6, find the sum of 20 terms of an arithmetic progression whose fourth term is 7 and seventh term is 13. The question is find the sum to 20 terms of an arithmetic progression whose fourth term is 7 and seventh term is 13. We have to find S20 and the fourth term is 7 and the 13th term is and the fourth term is 7 and seventh term is 13. The seventh term is 13. We know that the nth term formula is Tn is equals to A plus n minus 1 of D. Here we use nth term formula a plus n minus 1 of d. And we are given the data, the first whose 4th term is 7. That means T4 is equal to 7. And T4 is equal to 7. So n is 4. We say this equation number 1, and equation number 1 implies n is 4. A plus 4 minus 1 of d. 4th term is 7. So a plus 3d. 7, 4 minus 1 is 3. This we say equation number A. And the second given condition is the 7th term is 13. 7th term is 13. Here n is 7 also. So equation number 1 implies T7 is equal to A plus 7 minus 1 of D. T7, 7th term is 13. So 13 plus A13 is equal to A plus 7 minus 1 is 6, 6D. This we say equation number B. We can subtract these two equations for getting the value of D. So equation A minus equation B gives equation A is A plus 3D is equal to 7. And equation B is A plus 6D is equal to 13. We subtract these two equations, get A will be cancelled with A, and 6D plus 6D minus 3D is equal to 3D, and 13 minus 7 is 6. So D is equal to 6 upon 3. The common difference is 2. And put the value of this D in equation number 1, equation A. Equation A implies A plus 3D is equal to 7. So A plus 3, D is 2. A plus 6 is equal to 7. A is equal to 7 minus 6. We get value of A is 1. Now we find the value of A is 1, and the common difference D is 2. So we find the sum of 20 terms by using the formula Sn is equal to n upon 2, 2a plus n minus 1 of d. N is 20 because we find S20, 20 upon 2 twice value of A is 1 plus 20 minus 1, and the D is 2. So S20 is equal to 2 plus 19 into 2, 10, 2 plus 19 to the 38. This will be 40. And the sum of 20 terms is 400. This is our required answer. In question number 7, the question is how many terms of the series minus 8, minus 6, minus 4 up to so on make the sum of 90. So in question number 7, How many terms? Of the series -8 -6 -4, make the sum 90. Solution. Let n be the total number of terms. So Sn is equal to n upon 2, 2a plus n minus 1 of d. Here sum of n terms is given in the question 90, and the first term is in the progression -8, and the difference is -6 minus -8. So -6 minus minus plus, so difference is 2. By putting this data in the question, in the formula, the sum of n terms is 90, n upon 2, a is -8 plus n minus 1, and the difference is 2. So 90 is equal to n upon 2 minus 16 plus 2n minus 2. 90 is equal to n upon 2 minus 16 minus 2 is minus 18 plus 2n. 90 is equal to n upon 2. We can take 2 as a common. So minus 9 plus n. 2 will be cancelled with 2. 90 is equal to n. We can write this n minus 9. So 90 is equal to 9 square minus 9n. Here we get a quadratic equation, which is, can write n square minus 9n minus 90 is equal to 0. This is the quadratic equation. We find the value of n by using quadratic formula or factorized method. So the center middle term is 9n. We can make factor as n square minus 15n plus 6n minus 90 is equal to 0. So we can take n as a common. So n minus 15 plus 6. So we get n minus 15 is equal to 0. Here n plus 6 and n minus 15 is equal to 0. So either n plus 6 is equal to 0 or n minus 15 is equal to 0. So n minus 15 is equal to 0 gives n is equals to 15. So total number of terms is equal to 15. And here n is equal to minus 6. The number of term will not be minus 6. So we get the answer. The total number of terms is 15. Similarly, we can do question number 8. In question number 8, how many terms of each of the series? Here two parts of question number 8. 21 plus 18 plus 15 plus up to so n must be taken to amount 266. Explain the double answer. By using the formula of sum of the n terms, we can get the value of n. In question part 2 is same as part 1 of question number 8. And the other question we do in next session inshallah. Okay, thank you.